Hi guys, this is AP Stats answer for Free Response 2004, number 3. Nope, number 1. Let's try number 1 instead. All right, so I'm going to share my screen with you here. All right, and here we go. So we are looking at the moon's Earth orbit. The Earth's moon has many impact craters that were created in a solar system. So we can see here that they did a scatter plot that has something to do with age in billions of years. And then the y-axis is some kind of impact rate in, looks like 10 to the 16th grams per millions of years. So it looks to me like they're saying that the older that the crater is, the lower the impact rate. So possibly the early age ones. So how did they determine what the age of these were? Scientists studied 11 impact craters on the moon to determine whether there was any relationship between the age of the craters. So the earliest or the youngest age of the craters had a much higher impact than the older ones. So that would kind of make sense, right? Like if something hit just recently, it would make a bigger, possibly a bigger crater hole. They're saying it's a bigger impact. And the older the crater, possibly the lower the impact rate. Okay. In any case, they are looking for me to describe the nature of the relationship between impact rate and age. So what I would first be trying to say is that as age is increasing, what is happening to y? Y is getting smaller, right? So that's the very first thing that I would probably try to say. And then, is it linear? It doesn't look like it's linear, right? It's not going in a straight line. Matter of fact, it looks like it's going kind of like this. Okay, so I'm going to see if it will let me add an extra page here. And I'm going to go and answer part A right here. Okay, so I would say, and remember I got to do context, so I got to use all these words again in the correct way. So I would say something about the relationship between age, which is done in, age was done in, okay, that's kind of funky. The relationship between age, which is done in billions of years, of a moon crater. So there's my context. And the impact rate that is done in 10 to the 16th grams per millions of years of the moon craters appears to be negative. And what does negative mean? Meaning, as age increases, the impact rate decreases. And then the other thing I would say is that these relationships do not appear linear. Okay, so something along those lines. All right, so back to the original problem. Okay, so we got part A done. Then it says, prior to fitting a linear regression model, the researchers performed an impact rate and age by using logs, so the following computer output. So now notice they didn't make me decide where the logs go. They've already told it to me, and they've told it to me in a couple really nice, helpful ways. The first one is they've already given me the regression equation, so I can see that they took the ln of rate and the ln of age. So age was the x-axis, rate was the y-axis. Okay, And then the other thing I can tell is down here, they've given me ln of range. And remember that if they give us linear regression equations, this is A, this is B, in the general formula of y hat equals A plus bx. So in this case, it's going to be ln of y hat equals A plus ln of x with a times b either before it or after it. So it's going to look something like that instead. Okay. All right, so what are they asking for part B? Part B says interpret the r squared value. Okay, so r squared value, that would be right here. We never use the adjusted, we just use that one. Okay, and so this is going to be kind of a standard type of setting as well. So on this one, let's switch the color a little bit so you can see where that one is. So for part B, I'm going to say r squared equals 89.4%. That was the number in the printout. And then I would explain this. So our standard is approximately 89.4% of the variation. And now we'd usually say the variation in y. Now we're going to say in the variation in ln rate, and then we'd say of the impact crater is explained by, so again, I'm trying to make sure I do context, not just the two words rate and whatever the y was, but actually trying to talk about the craters again, is explained by a linear relationship. So remember, it became linear when they brought in the ln, so we get to still say it's a linear relationship between ln rate and ln age, which remember was the age of a crater. And I could put in the units again here that I did on the same spot. Okay, so I could even say using same units for age and rate in part A, if I don't want to keep rewriting it. Okay, so remember the key thing here is I'm using the percentage, that it's the percentage of a variation of y, that we're calling it linear, and then we're explaining what the x and the y are in the problem. Okay, all right, so part C says comment on the appropriateness of linear regression for modeling the relationship between the transformed variables. They're saying after you've gone ahead and changed them, you brought in the ln's, how did they look? All right, so remember the first scatter plot did not have any of the transformations in here. Okay, so I can tell that there is no linear here. However, they did give me a residual equation, and the residual equation says fitted value, which means they have done ln's. Notice that the x is no longer the same, right? Over on x side, we went from 0.4 to 1.4. Now we're going from 3.5 to 8.5. So now this side is ln of x, and this side is going to be the residual of ln of y. Okay, so they've already told us that they've transformed it. When they transformed it, we got a fairly decent r squared value. That looks better, but really what it comes down to is what does the residual graph look like? Well, what I see in the residual graph is that it's got some kind of parabola shape to it. Can you see that? Okay, it does not look like just random gunshot. It doesn't look like they're all randomly associated. It looks like a U shape. So that's the big thing that I want to say in part C. Okay, so in part C, they asked me, their question was, comment on the appropriateness of this linear regression for modeling the relationship between the variables. And I would say the transformation of ln of age and ln of impact rate of the moon's craters may not be the best transformation for these data. Why? The residual plot appears to be parabolic, where resid plots should look random. Since there is a pattern to the resids, we know that this transformation did not make a linear relationship with the transformed variables. Okay, so shocking here, they actually wanted you to say that this is not a good fit. So they're kind of hoping that you're going to look at it and see, oh, they changed it, it must be better. Okay, so they still want you to call them out on stuff. Notice that I did check to make sure that the x's were changed as well when I checked the residual graph, and that I am calling it a residual graph. Okay, so those were the key ideas for those. All right, check back for the next video for the second FRQ if you would like a walkthrough on this one, on that one as well. That'll be the next one.